Hello, everybody. Thank you for attending our talk today. Today we are going to be talking about steps towards achieving a secure Linux server. So I'm Karissa Sanchez. I graduated from MIT in June of 2024, and I've been working at Microsoft since August of 2024.
I'm Angelina. I also work at Microsoft. I've been there for about 2.5 years now, and Chris and I both work together on the Linux systems group team. So the intended audience for this talk is newcomers to Linux who want to learn the basics of server security. We're going to introduce key concepts such as defense in depth, discretionary and mandatory access control, and isolation through containers and virtual machines. And we'll also talk a bit about how to use firewalls and the often overlooked threat of social engineering. Our motivation for this talk comes from the high number of attacks targeting Linux systems servers each year. While Linux is known for its stability and security, even mature open source software has proven susceptible to exploitation. And a significant portion of these attacks involve web-facing services, so this makes web servers a prime target. So now is a critical time to pay attention to the security of your systems. However, if you're a beginner just setting up your first Linux server, security might not be the first thing on your mind. We ourselves are beginners, so we understand how overwhelming all this server stuff can be. And if you're new to this and adding on security, this can be a little bit daunting. For instance, let's say you search up Linux server security best practices. You'll find a lot of results, like 40 Linux server hardening tips, 26 tips. So all these articles, they're great articles, but it might be a bit much information if you're just getting started. So we're here to help you by just talking about a select few of these security practices.
So throughout this talk, we kind of want to work with a toy example to demonstrate all the security practices we want to implement. So our end goal here is to have a mail server and a web server both running on an Ubuntu VM. So in this diagram, we can see that, we have these two separate processes running. We have our mail server and our web server, and they both share a file system and an operating system. So what could possibly go wrong here?
Okay, so we're going to go into our first demo. So throughout this presentation, we have a few demos, and I'll be playing the role of an attacker, and Krista will be the web server owner. And I will try to mess around with her web server, which we wrote and deliberately put holes into for the purpose of these demos. Yep. So here you have her web server. There's a login, and there's a sign up. It's pretty basic. I'm going to try to log in without an account, and I see that I get an invalid password message. So now I'm going to sign up for an account. So sign up, successful, and then log in. It just says welcome. So pretty simple, not much going on. We're going to go back to the login, and I'm going to check if this is vulnerable to code injection. An easy way to do that is to just put a single quote as the input, and we see we have an internal server error, which is different from that invalid password message that we had earlier. And this indicates to me that there is improper input handling, so this might be vulnerable to code injection. So I'm going to try a few different commands to see what I can run. So here I'm echoing hello, and that does print out. So now I'm going to try to run a system command to see if I can just list out the files. That also works. I can see the file names. In particular, we have index.html, which is probably for the homepage of this website. So I'm going to try to write to that file. So this command writes to index.html. It writes the message, you've been hacked, in red font. So I hit login, and then if I refresh, you see I was able to write to that file.
So it seems like my web server may have been hacked by Angelina. So let's see what can be done to prevent this in the future. Before we go into the actual security practices we want to implement, I just want to have an aside about the scope of this talk. So the website that we made was intentionally written with vulnerabilities that would make it easy to exploit with a code injection attack. And that is okay because this talk wants to focus on what can be done from the perspective of the Linux system. So that means it's okay if we are running code that is written with bugs, because we don't want to assume any trust in the code that we are running. Instead, we want to be assured that even if we are running really buggy code, our system still has some safeguards in place to protect itself. And yeah, throughout this talk, we're going to start with some higher level security principles, and we're going to show how those can be implemented on our system.
Okay, before we get into more details about mitigating that vulnerability, we're going to talk about what we're dealing with here. So your attack surface is the set of all possible entry points an attacker can exploit in a system. In this talk, we will focus on the attack system of our web server. As we've seen, there's a major bug in the login page, and through it, I was able to access the file system and run OS level commands. In another demo, we'll see that you can even access the mail server using the same exploit. So our main strategy is going to be defense in depth. This means having multiple layers of defense so that even if one fails, there's a backup that can still mitigate the attack. For example, let's say we have some sensitive data that we're trying to protect, and we have 3 different security components implemented to harden the system. So if, say, layer 2 fails, we still have layers 1 and 3 as a backup. Now, each of these security layers is set by people, so that makes them susceptible to human error. So while it may seem redundant to have multiple layers of security, this redundancy allows more room for error and reduces the number of successful attack vectors.
So as we get into our first security practice that we want to cover, we want to talk about access control. And access control is a security measure that determines who can access what resources and under what conditions, and in addition, what that access looks like. When we talk about access control, we want to keep in mind the idea of least privilege, which means that every program and user should only operate with the minimum amount of privileges that is necessary in order to complete their job. So if we want to look at a real life example of access control, we can think about a school grading system. So let's say we have someone who is a teacher, and then we have a bunch of students, and we want to allow the teacher to have permissions to read and write to all of their students' grade files, but each student is only going to have read access to their own grade file. And while it wouldn't necessarily break the grade book if each student could read to other students' files, we just don't want to give them that access because they don't need it, and so we're still keeping least privilege in mind. So yeah. We also want to go into 2 main types of access control. We want to talk about discretionary access control and mandatory access control. With discretionary access control, users have the ability to set permissions of their own files on their system. So this provides some sort of layer of defense, but it does rely on the user to uphold necessary permissions. So I'm sure you can imagine that as the system gets more and more files on it, as it gets more complex, it becomes more complicated for a user to uphold secure security practices and keep track of what permissions they have set. And that's where something like mandatory access control comes into place. So this is where we're able to enforce a centralized set of policies that apply at the system level. And with this, we are taking some of the responsibility off of the user to enforce security practices, and we're also removing some of the trust that we have in the user. So we could have users that maybe have like bad intentions, but we still have some centralized set of policies in place that are enforcing access. We can also look at discretionary access control on Linux systems, and this takes place in the form of file permissions. So file owners have the ability to set the access for their own files. If we look at a command like ls-l, this will output all the files in your directory and the permissions associated with these files. So if we look at the very left, we see like 3 sets of read-writes, and what that means is that the first read-write means that the user is able to read and write to index.html, the second one means that the group is able to, and the third one means that anyone on the system is able to read-write to index.html. If we compare that with a file like login.php, we see that only the user is able to read and write to the file, but everyone else on the system only has read access.
Okay, so continuing on with the demo, we saw that I was able to write to that index.html page. So now Karissa will update those file permissions so that I no longer have write access.
Yeah, so if I go back to my web server, I can see that it's been hacked. So I want to see what I can do to prevent anyone from writing to my web page. So if I list out the files, we can see that Yeah, index.html, as I mentioned before, has write access for anyone on the system. And that's not very secure, so I want to try to fix that. So first I'm going to remove the red text that was added to my web page. And then I'm going to change the permissions for index.html so that only the user has write access, and now we can see that, nice, everyone else only has read access. So hopefully, in Angelina's next attempt, she will be unsuccessful.
Okay, so, wrong one. Okay, so I go back to the website. I see she's cleaned it up. So I'm going to run the same command to see if I can rewrite that message on the home page. And this time I refresh and nothing comes up, and that's because discretionary access control is blocking the attack since I no longer have write access. Yeah, so in this scenario, even though it successfully blocked the attack, this might not be the most practical solution because you'd have to carefully configure the permissions for every file on the system. And while it's important to ensure that file permissions follow the principle of least privilege, meaning the permissions are set to only what's strictly necessary, this approach doesn't really scale that well. So this is where mandatory access control can come in to limit an attacker's reach. So mandatory access control is a supplement to discretionary access control. It adds additional security and in fact even overrides discretionary access control. So users cannot override MAC policies even if they own the file. Two of probably the most popular Mac systems are AppArmor and SE Linux. These are both Linux security modules, or LSMs, which are a framework that provides support for additional security models, with the primary users of LSMs being Mac extensions. In our demos, we're going to be using AppArmor, which ships with Ubuntu systems. It's a path-based policy model, and you'll see what that means in a bit. It allows you to create profiles that define what a program can access, so which file paths and resources, and how it can access those, so read, write, and or execute. Alternatively, there's SE Linux, which ships with Red Hat-based distros. This one is a enable-based policy model, so you can assign a security enable to your files and processes, and access is granted based on those labels. It's a bit more complicated to use in AppArmor, but it provides more fine-grained mandatory security enforcement. So once we implement AppArmor into our system, this is what it would look like. So if I were to try to write to that index.html file again, AppArmor will check if the web server has access to that file path, which it should because that's the home page, so it should still at least have read access. But AppArmor will also check if the web server specifically has write access to that file path, and that should not be set, so the attack would be blocked. So now we're going to see that in actions. I'm going to exploit that same vulnerability to access the mail server and send spam mail, and then Karissa will use AppArmor to restrict our Apache web server to only being able to read from its directory. And then we'll see that I can no longer access the mail server. Okay, so we're going to assume that I know the mail server exists. And I'm going to cat the contents of this postfix config file to see if I can find a domain name. So here I see my domain is set to oss-demo.com, so I'm going to note that down. And now I'm going to see if I can find some of the users of this mail server, which is typically listed under this directory. So we see we have demo user and we have root. I'm going to try to send spam mail to demo user. With this command, it sends 100 spam messages that just say spam to demo user at oss-demo.com. Okay, so I hit login and it takes a little while, probably because it's sending 100 mails. And yes, hopefully that worked.
Okay, so yeah, I'm just going to check my email right now. And oh my goodness, wow, there are so many spam messages there now. how could this possibly happen? So I'm going to investigate a little bit, and yeah, it just says spam message. And this is from www.data, which doesn't really give me a lot of information about who sent this. But to try to prevent this kind of attack, I am going to use AppArmor to hopefully restrict my web server. So yeah, let's do that. So here I'm looking at the default profile for Apache 2 in AppArmor. In here, it includes some instructions on how to set up an AppArmor subprofile. So now I'm going to open the conf file for my web server and do that. So yeah, we see that we have the subprofile is defined here as Apache 2 demo server 0 secure. And we can open that file and see the file permissions that we're allowing. So yeah, here we're going to say that anything under the path of demo server 0 secure is read access only for our web server, and it is only able to write to logs. So hopefully this will now prevent some sort of attack from the web server to our mail server. Next, we can reload the AppArmor profile. And then we can check the status of AppArmor and see if the profile is loaded and enforced. So here we see that 56 profiles are loaded and all 56 are in enforce mode. And among those is the one that we just created. And now we can just restart Apache 2 and hopefully our system is more secure now.
All right, now that mandatory access control is in place, we're going to try that same command, send the mail again, and see what happens. Okay, so this time I press login and there's no delay, so maybe nothing sent this time. I'm going to check to see if I can still cat that postfix config file. And we see there's no output, and that is because we can no longer access the mail server components because AppArmor is restricting the web server to only being able to read from its own file path, which doesn't include any of the mail server's file paths. So that successfully blocked the attack. And now we want to have defense in depth. So we're going to look at an alternative way that we could mitigate the same attack. Isolation is an important security concept. It separates parts of a system from one another, so this limits the scope of attacks by preventing one compromised component from compromising the rest. This could be in the form of using two different physical machines for two servers, but that would be kind of costly and inefficient. So what if we could use just one physical machine, but still have some form of isolation? The containers and virtual machines could help here. While they both provide isolation, containers only virtualize the application layer, so they're more lightweight than a VM. Virtual machines, on the other hand, also copy the entire OS kernel and use the hypervisor to communicate with the host OS, so this gives them a larger performance overhead, but they also provide stronger isolation.
So now if we update our system diagram to show containers, we can see there's a lot more isolation enforced in our system. So our mail server now exists in its own container, our web server exists in its own container, and so does the database that our web server uses to store usernames and passwords. And each of these containers has its own files that it can access, which allows us to have a more secure system and hopefully prevent any web server interference with the mail server. And I also want to highlight that we are kind of using virtualization still just by virtue of us using a virtual machine. So if we look at the broader context of our system, our VM exists in some physical machine somewhere in a data center. but we cannot tell that we are sharing this host machine because there is virtualization here. So we are interacting with a guest operating system, which interacts with a hypervisor, which interacts with the host operating system. And on this same physical machine, there could be other customers running VMs, and thanks to this isolation, we cannot tell.
Okay, so we're going to say I use that same exploit to spam the mail server again, but this time, instead of AppArmor, Karissa will use a Docker container to isolate the web server and its database from the rest of the system, and then we'll see if the attack still works after that.
So yeah, I'm going to set up the containers. So they are defined in the file docker compose.yaml. So I can run this command to create the containers. And here we see that, yeah, the network to communicate between the database container and the web server container is created, and so are the containers themselves. Now I can check the status of the processes, and we see that, yep, our containers are running, and you can see that our web server container is at port 81. So we can go and check if our web server is still running. Okay, and so to check this, we're just going to try a sign up and a login to see if we can still interact with the database. So sign up successful, and then, yeah, the login also worked. So we were able to set up containers for our web server and its database, and it didn't break anything. So hopefully now we can also prevent any sort of access to our mail server from our web server with these containers.
Okay, so now let's see what happens now that everything's isolated. So I'm going to try to list that var mail directory. And you see no output because the web server is in its own container now, so in the point of view of the web server, there is no mail server that exists. And just to show you what happens if I run ls, I can still see those files because those are the web server's files, so they're in the same container. And just to double check that we can no longer access any of the mail server stuff, I'm going to run this command which looks for references to a mail service. It'll echo 1 if it finds any, otherwise it'll print 0 and we get 0, because everything is isolated now.
So nice. We were able to use AppArmor and containers in our system, and now we also want to talk about providing some protection over the network for our system. So in order to do this, firewalls are a great tool. They prevent attackers from attacking over the network, and they're going to inspect the traffic and verify this traffic against a set of user-defined policies and filter out traffic which does not comply. These policies can apply to different types of traffic. It can be incoming traffic. It can also be traffic from our system going outward, and it can also apply to traffic being forwarded. So the end destination of the traffic is not our system, and it did not originate from our system, but we can still prevent any kind of routing with firewalls. If we want to look at this in a diagram, we can see that here we have incoming traffic, and it is going to be passed through the firewall, which is a table of rules that filter. These rules can be based on the source IP, the destination IP, the port number, or the protocol. And depending on how the traffic is analyzed and passed through these filters, we can either decide to accept the traffic, we can choose to drop it and not send any response, and we can also choose to reject it, which sends back some sort of error message. If you want to configure a firewall, IP tables is a useful tool to do so from the user space, and it provides a command line interface to do so. But it could also be possible to configure some sort of network access management still using an external tool. So since we created our VM in Azure, if we looked at our resource webpage, it already came with some default policies for network access. And we actually had to loosen those rules because we wanted to use remote desktop protocol. So we were able to modify access using some external source. That comes with the benefit in that you have less risk of accidentally being blocked out of your system. So let's say from user space, you say, OK, I'm going to block any SSH connections. And then you accidentally get logged out of your system. Then you're kind of trapped. You can't go back into your system to change that control because you blocked out SSH. So now if we look at our updated system with our diagram now, we still have all the isolation and the mandatory access control we implemented earlier, but now we also have an extra layer of protection in the firewall. So now any network incoming or outgoing traffic is going to be first filtered through our firewall, and only the traffic that we allow is going to be passed through. So crucially, this traffic is not safe, but it is controlled. So we at least are able to define what we do and don't want coming into our system.
Okay, no demo for the firewalls, but we do have some final general housekeeping tips for you all. So make sure the only users on your systems are users that should be on the system. Use SSH keys in place of passwords if possible, and enable multi-factor authentication. If you are using passwords, make sure that they're strong passwords and avoid reusing credentials for multiple sites. Remove any unnecessary background processes or packages because they could be housing malicious code and increasing your attack surface. Keep backups. One nice way of doing this is actually through Docker containers, because if an attacker somehow uploads something malicious, you can just restart the container and it will get rid of that. Keep your system up to date so that you have the latest security patches, and incorporate some type of static application security testing, which can analyze your source code or binaries for vulnerabilities without actually executing the application.
Okay, so when we said that general housekeeping was the final tip, we lied, because we have another tip, which is social engineering. This doesn't apply specifically to Linux systems, but we do want to still mention social engineering because this is a security talk, and this is a pretty commonly used attack vector. So while all these security tools we are using become more and more sophisticated, it becomes more likely that the person operating the system is the weakest link in the chain of defense. And as a result, phishing is the most common data breach vector. And data breaches are really expensive. According to IBM, a data breach costs on average 4.9 million USD. So as you can imagine, if we are able to mitigate the use of phishing as a data breach vector, we can save a lot of money. So how do we prevent social engineering attacks? The first thing you could do is just stay aware, stay up to date about new and common attacks. Some common attacks include phishing via QR codes. Some people will use AI to better impersonate more reputable sources. So whereas previously maybe you can check a suspicious email and see like, oh, the spelling or grammar looks a little bit off, now people are using AI to send really polished messages. And also if you're getting any messages that prey on strong negative emotions, promise you riches, or try to instill some sort of sense of urgency to act on the message, that is likely phishing. So also just want to say, be careful when entering sensitive information like usernames and passwords and any credit card information or just personally identifiable information. But if you do, multi-factor authentication is a good tool to use so that if you accidentally do end up handing over your credentials to your system, there is still some sort of second check to make sure if you actually intended to log in using these credentials.
Okay, to summarize what we went through, we applied defense in depth using multiple security tools with some redundancy. We enforced access control through both discretionary and mandatory access control and followed the principle of least privilege. We demonstrated isolation in the form of containers to prevent interference between services that should not be able to communicate with one another. And we discussed how firewalls can protect from attacks over the network. So yay, our system is more secure.
Yeah, and what we mean by that is maybe something more along the lines of, oh yay, my web server is more difficult to hack now. So we don't want to promise that anything's ever going to be completely secure, but we've at least succeeded in making it a lot more difficult to hack, and we've made ourselves a much less appealing target. So yeah, thank you for listening, and we have some additional resources that we used. So yeah, we welcome your questions, or if you want to come speak. Yeah? That is a good question. Maybe if you still want to, let's say there's like some sort of system that like you want to communicate, maybe you want to still indicate that it is the firewall preventing that sort of access and not necessarily like some sort of network issue. Yeah? Oh. Okay, yeah.
Great. Anyone
Thank
else?
you. Oh, wait.
I think it depends on your use case. I don't have any experience with SE and Linux, and I only learned AppArmor to do the demo, so I can't really say much. But AppArmor is supposed to be easier to use, but SE and Linux, you have more fine-grained control. So I don't think I'm the best person to answer that question, but.